Hello, how y'all doing? Hey Harvest, how's it going? All right. So, I know this is a little bit later than I usually stream, but I had to do a bunch of stuff earlier today, and I was traveling earlier this week, so I was kind of scared of being super jet lagged, but I'm doing okay, so I thought I'd hop on. Yeah. So today, I wanted to look at automating a bunch of the stuff that we did last stream. So throughout the stream, we did a bunch of manual steps in order to get to this final sample, um, which is effectively a USB worm that performs clipboard hijacking, um, which is effectively replacing, let's see if I can find it, which effectively replaces the clipboard contents if it sees clipboard contents containing these characters with cryptocurrency addresses. So what this is meant for is if you had a Bitcoin wallet or a cryptocurrency wallet on your machine that you were copying the address for to send currency to, say from like a website or a hot wallet from a crypto exchange or something like that, this would effectively replace that address with a cryptocurrency address that this malware author controls. So that's what I was just about to get to. So big shout out to Donald on our Discord. I asked if everybody wanted to take a look at the samples in our Discord and to determine what malware sample this is or what malware family this belongs to. And it's actually like a really old version of Phorpiex, which is it's a malware family that's been around for a long time. It's had many different iterations. Even I'm sure most of you have seen Phorpiex at some point. There was a while where Phorpiex was sending emails, like email spam, that would basically say that they've hacked your computer. And then they would use like breached database passwords that were associated with emails and then put that in the email subject header to make it like more believable that they hacked your computer. And then they would basically try and social engineer you into sending them cryptocurrency. This is a really old version though. It uses IRC and a bunch of old techniques that Phorpiex no longer uses from what I understand. But yeah, this is a nice fun sample to look at. So a few things that I wanted to look at automating was getting to this point, so unpacking it. We can do that in a few different ways. I'll show you those different ways because we basically manually unpacked it with a debugger last time and looked at the first stage, which was highly obfuscated. And I kept saying kind of that whole time, we don't really need to do this. We could basically do this in different ways, but I didn't explain those ways. So that's what I wanted to do this stream. So first and foremost, I can show you like a really fast approach to unpacking this. This isn't necessarily what you want to do all the time because it can be incorrect in that we're going to run the sample and let it inject into a process. And then we're going to use an automated tool to carve the portable executable that was injected into that remote process automatically. So we don't have to attach to it with a debugger. We don't have to analyze it statically. We can just simply dump and carve out that remote process automatically. So for those of you who have not heard of it, there's this super awesome project from Hashrazade called Hollows Hunter. So I'll just go to Google and pull that up. So this is a really good project for identifying. So basically it scans all processes and recognizes and dumps a variety of potential malicious implants, replaced implanted PEs, shellcodes, hooks, and memory patches. This has had many changes over the years and many different iterations, and Hashrazade has done a ton of work with this in PE Sieve to make like a really cool automated tool. And this makes identifying portable executables in memory and carving them out extremely easy. Like it's point and click effectively. But the thing I would like to point out before, there's always the caveat with using automation. This cannot always get you, one, a clean portable executable, and two, it does have the potential for false positives. I have never really seen false positives with Hollows Hunter, but there's a lot of other automation frameworks that can potentially have false positives. And we'll be effectively running this at the point in time in which the injection has already taken place. So the problem with that is you can always have the portable executable was injected. The malware can modify that portable executable in memory. So it could, in fact, be different at the point in time that you're dumping it from memory than the original portable executable that was injected. I don't believe that's the case in this instance. But yeah, here I'll throw the Hollows Hunter link in the chat just so y'all can check it out. It comes with Flare VM. So if you do use Flare VM for your analysis environment, then you will find it there. And that's what this VM is, so we can use it. So just to kind of show you how this works before I let this thing inject, if I pull up command.exe, and then we need to run this with an administrator prompt, and that's just so Hollows Hunter can get access to a bunch of different processes, or get process handles to elevated processes. And then let's go into temp, because this is going to create a output directory. And then if we just type Hollows Hunter, it still doesn't have access to some of these core Windows processes. That's just because they don't have, or we don't have those types of permissions for accessing these core Microsoft Windows processes, but we will be able to access the processes that we want to access in order to dump the portable executable that's injected. Hey Leon, how are you? I'm just gonna open a bubble here while this scans. There's no malware currently running on this machine. At least I restored a snapshot and there shouldn't be. So I'll just let this run and then show you what kind of the output looks like and the options and stuff like that. Because there's a selection. Oh, there we go. Yeah, you're right. There's a Unpack tool from HasherZade also may be useful. Oh, cool. Okay. Let's take a look at that. Yeah, I would say arguably HasherZade puts out some of the best tooling that's currently available, all for free. So if I know HasherZade does some, I can't find it right now, but I do know that on their Twitter, they posted a fundraising link. So I know they do like a bunch of different fundraising every year for different tooling that they put out for free. So if you have spare money for it, you can check those out. Oh, cool. Yeah, you linked it. Thanks, Heyo. Okay, so is this dynamic unpacker on PE-sieve? Waits for the unpacked payload dumps. Okay. Is Unpack on here? Because I might try it out. But yeah, and shout out to Donald for identifying that this was Phorpiex on our Discord channel, by the way. I can't remember if I said that already. Okay, it doesn't look like Unpack's on here, but I do kind of want to try this out, so maybe I'll download it right now. So let's do the 64-bit one. This is a 32-bit sample, so I guess it's going to inject into, it injects into itself, so that should be straightforward. All right, let's see. Okay, so supplied malware will be deployed. Use it in a VM only. Okay, so we just provide an input exe and that's it. Path to the image for which the malware was run. And then scan options. All right, I think we should just run this with the original sample and see if it works. Thanks, Heyo. That's cool. Like in theory, I think this should work because it's based off of PE-sieve. So, and then I think There was this 7, yeah. Okay, and then just double checking. I do just provide the /exe. Okay, cool. All right, let's let it rip. Let's see what happens. Missing parameter, timeout. Let's just do 0. Cool. Let's see if it works. And then we're going to try some fun stuff after this with the unpack sample. So it doesn't look like there's a child process under this. Weird. I wonder how it watch respawns from main.exe file. Please remove selection. Thanks, Tom. I should, would that happen in PowerShell? Maybe I should just run this from PowerShell. Okay, I think, do you know what I should do? Is, it seems to not stop when found, since timeout is infinity. Oh, so did it already? Module path retrieved. Okay, okay. So if I go back to, does he usually just dump in the current directory? Python wrapper, Unpack lib. Okay, I kind of just want to see if this will work with, oh yeah, you remember in the final PE there was the anti-VM stuff. So maybe that's the problem. Okay, let's just run this and then see if it deletes itself, because it self-deletes and that means it's detecting the VM. So let's do that. It's running. Okay, did it self-delete? It did not, but it did exit. So maybe I can't do it manually in this VM, but let's run Hollis Hunter just in case. Yeah, because it would have injected into itself. So I'll show you a different way so we can get around the anti-VM stuff. I really need to harden this VM, but okay. So what we can do instead is just break on, it was write process memory from last time. We effectively did this last time, but I want to see if we can carve it. Okay, so let me back up actually real quick for those of you who were not here last time. So, okay, so first and foremost, we have a debugger. And when you suspect a sample is unpacked, typically a workflow that you want to use, let me pull up some unpacking stuff from the course that we have. Sorry, I'm just drinking a pop, which is not a good idea. So unpacking. So I'll just kind of show you what a typical unpacking workflow looks like. And then we'll use something else to fully automate this. But basically when you identify that a sample is unpacked, or sorry, that is packed, and the way we did that last time was looking at the, actually, let me just pull that up. Hold on. So it was a self-extracting archive, but I'll just show you kind of what the DLL that was being loaded by the self-extracting archive looked like. I don't want to redo everything again just because, you know, we did it already last stream and it's recorded so you guys can check it out on our YouTube channel. But this is what, so if you open a binary in IDA and you want to determine if it's packed or unpacked, whatever, if you look at the entry point, say DLL entry point, there's a bunch of indications that this DLL is packed. So this is what's being loaded by that self-extracting archive. And the first indication is that there's very few imports, right? So if you had a legitimate application, you probably would have more than just 4 imports unless it was a very basic program. Another indication is that there are very few functions. So here we only have about 5 functions. And if we go, so if I hit like Control E, we can go to the entry point or all the accessible exports for this particular DLL that IDA has detected. And here only one export exists, which is also very abnormal for a DLL. Typically, you would have export functions that are exported by the DLL that are accessible via a ABI, or application binary interface, I believe it stands for, in which a external application, so a standalone executable, can call those exported functions. But in this instance, we don't have any exported functions. We only have this DLL entry point function, which is basically every DLL has an entry point. So that's all to say that if we want to determine if this is packed or not, that's another good indication because it doesn't have any exports. Another thing we can look at is, that our data section, I think, could be a good indication. But if we look at the main function here, it's highly obfuscated, right? We have like all of these operations. We basically have like one giant function, the sub2FB 1000 function that spans the entire text section. This is also very abnormal. In a legitimate application, you wouldn't typically have all of the functionality within a single function, and it would be much more readable than this code, which is quite difficult to read. We marked up all of these like get module handle functions and stuff, but those weren't there before either. Sorry. Again, we can look at a few different things. If we look in the data section, there is a bunch of seemingly innocuous data. Again, in a legitimate application, you would have things like strings and all of these things that would indicate it's legitimate. The binary that it's actually extracting data from is on disk in this self-extracting archive. So it's actually unpacking this blindworm.cab file. Again, last stream we looked at the self-extracting archive. And if we look at this is actually not a legitimate cab file. It's just a bunch of encoded data. So looking at this in conjunction with that DLL, we can determine, okay, this is probably packed in some way, shape, or form. So going back to kind of the unpacking theory, this is a little bit more advanced. I know this is kind of a beginner stream, but typically what you want to look at when you're performing unpacking is a few different things. First, you want to determine that the file is packed. So sometimes programs like Detected Easy here. So if I open that DLL that was obfuscated, sometimes Detected Easy, which is this really good application that has a bunch of embedded signatures. So if I look at, like, if I click on the signatures button, it pulls up all these different signatures that Detected Easy can use to detect various things. This includes things like packers and self-extracting archives, like we used it to identify the NSys installer last stream, etc., including like compilers and linkers and stuff like that. So this is all very good information to have. And sometimes it can actually directly identify the type of packer that was used. In this instance, that's not the case. We just get a few things like, okay, apparently there's an embedded Borland Delphi compiler, but there's also a Visual C C++ compiler. So this might be a false positive because I believe it was just compiled with Microsoft Visual C and C++, which therefore would not be compiled also with Borland Delphi, but there might be an embedded attribute in there. Yeah, we're actually not going to look at Delphi, so don't worry. hey, Split Splash, how's it going? Okay, so going back to the unpacking piece. So if you can't get things like, Hollow's Hunter to work properly, then you need to take a different approach. And that's kind of this generic unpacking approach that I was just showing. So if DI can't detect it, but we used all of those things that I described, so like the exports and number of functions and things like that to determine that, okay, this is probably packed, then we move on to these next steps. So we move on to this manual unpacking step, which basically we want to set a bunch of breakpoints in our debugger in order to break on functions that are related to the unpacking process. And by process, I mean all these steps that are required in order to unpack and inject into a separate process. So for that, we have a script, but just to kind of show you the general workflow is we want to look for memory permission changes. We want to look for memory allocations, any mapping and unmapping that takes place in memory. And if we do hit a breakpoint on any of, say, those memory allocations or memory changes, we want to track those memory reads and writes at the locations that those were made, et cetera, et cetera. And then at which point in time we monitor for those changes. We want to look for any decompression that happens, any permission changes that happen, any execution at those external locations that were allocated in memory, whether there was a PE or MZ header that was written to a location, etc. And then, and as a last ditch effort, if the process exits, we also want to dump at that point in time as well. And the reason being is that we want to try and get the ideal scenario where we get a full dump, fully unpacked portable executable in memory if we can, and then dump that portable executable, load it into a disassembler like IDA, and then check it with detected easy. So that's effectively what we did last stream. It also did process injection, so we followed these steps as well, which basically looks for similar things, but looks for injection techniques. So we look for things like writing into remote processes. We look for things like unmapping and writing new images at process locations. We look for things like loading DLLs, etc. And then typically you want to unpack a portable executable before it's actually executed. So the unpacked DLL or executable in memory, you basically want to get to that before it's executed, because what I described earlier, the malware can make changes to that memory image. So therefore you don't have the original malware that was executed. So I hope that makes sense. And typically you want to dump the process at what's called the original entry point. So basically that's the original point in time at which the unpacked portable executable, or the address at which the unpacked portable executable is executed in memory. So I know that's kind of a lot, and I just said a lot, but I'll kind of show you what that looks like just to give you an example, and then we can move on from there. Let's open that original portable executable. Let's disable all these for now. And then I'm going to re-enable them when we get to the entry point. So basically I'm just going to keep hitting run here until we get to, this should be good. Okay. So x64 debug, for those of you who do not know, has a breakpoint that is automatically set on the entry point address of this portable executable. So if I open die again, and then I open that self-extracting archive, then here we can see the entry point address 40330B6. That's basically the breakpoint that's been set automatically by x64 debug. And then we've broken here. So the next thing I want to do is I have this script. It's on our GitHub. I can link that real quick just to show you exactly what I'm doing. So I really need a Twitch bot. But basically this is the script that I'm using. And all this does, it's really straightforward. It just sets a bunch of breakpoints on commonly used APIs that are used for unpacking. Okay. So the next thing we want to do is use this script, and I've already loaded it into x64 debug, so we don't have to do that again. But I'm going to hit spacebar, and then it's going to enable all those breakpoints. And then it says the script finished. Okay, and then I'm going to hit this run here, and basically we're going to, I'm going to disable ZW create section because that's called quite often by common functionality. Okay, so it's doing its thing. Okay, and then we get a write file. So this is just the self-extracting archive writing stuff. The blindworm.cat file is written here, which is the one I mentioned earlier. Then we see that DLL, that obfuscated DLL that was being written. Okay, you guys can't see that, can you? Because it's in the bottom right. Hold on. Basically, I was just pointing to this stack address. Okay, and then we get another write file. Okay, so then we start seeing the injection functionality. So in order for the process injection to work, we see a call to ZW unmap view section, which is very common for malware to do. And then if we look at, I think this is the first loader, if I remember correctly. But if we look at this address, so we can see, you can just barely see it here, but there's something that we want to look at. So in the bottom right here, see at that, yeah, this is the first loader, so I'll keep letting it execute. But basically, you kind of always want to look for referenced addresses throughout the execution of the unpacker to make sure that you catch any of these portable executables that are being used in memory. But I'm going to let this continue executing. So what do we have here? Okay, so system.dll was loaded. Okay, so virtual protect was called. Okay, so now we have supersonics.dll. Okay, so also extremely common during the unpacking process, we have a second process that's created. So if we look at create process A, which is the function that was called. So this is a Windows API function that's being called by the unpacker. This will basically create a new process with a number of different parameters. And let's see, is the suspended? As you can see, there's a whole bunch of different information that you can provide to the process being created. What I wanted to show you is first the application name that's being created is important, obviously, because we want to know what process is being created. Sometimes malware passes command line parameters, so we want to look at those too. And then we see things like process attributes, which is provided in the security attribute structure, but I believe it's the creation flags that we want here. Yeah, so, okay, so if we look at the, let's see, where are the creation flags? So 1, 2, 3, 4, 5, 6. So the sixth parameter that's being passed to create process memory. If we look at that here, it's this number 4. And if we go back, what that number 4 means is if we look at so these are the process creation flags. So these are flags that you would set in the program. These would normally have nice names not like this and not be that number 4. But in this instance, the number 4 is being shown in the debugger because it doesn't have these mapped enumerations. But here we can see that the create process suspended is being passed to this create process call. So if we let this execute, so I'm just going to hit execute till return in our x64 debug session here. Then we can see in our process explorer window, we can see a new instance of this self-extracting archive executable was created in a suspended state. And the reason we know it's suspended in our process explorer window here is because it's grayed out. And then if we look at the properties, it should say somewhere that it is suspended. Let's see, threads, RTL user start. So yeah, see it says that the main thread is in the wait suspended state. So that just means that the process is effectively in a suspended state. So what we can do here is continue execution. So call to virtual alloc is being made. So we want to set a breakpoint at the allocated virtual address. So hard one access right. I believe this is not the unpacked portable executable. That's okay. Okay, so it's reading from the remote process that it just created. So then it calls nt unmap view of section, which again is very common since it has to unmap the remote process that it's about to inject into. So basically what this is doing, it's going to overwrite the remote process with a unpacked portable executable. Okay, so let's look at what's being passed to remote process here. And we can see since x64 debug is great, we can see in this EAX address here that an MZ header is being passed. So if we right click and go to follow and dump, then we can see that at this address there is a unpacked MZ header. Unfortunately, this is the portable executable that we want to unpack in its entirety. So this doesn't always happen. Sometimes it writes it section by section, including the header being separate. Sometimes it clobbers the header, so you can't see like an MZ header being written. sometimes there's a whole bunch of different barriers in place for you to do this. So this is a very kind of beginner example of a process being injected into using a fully accessible portable executable in memory, but still a good example nonetheless. So what I kind of wanted to see was whether we could dump this using Hollis Hunter now, because it should be able to detect this. And if it doesn't, that's okay. Okay, so it looks like it didn't detect it, but I'm going to let it do the injection, and then Hollis Hunter should pick it up. Sergey, can you send me the docs on conditional breakpoints? Because that's pretty sick. Are you using like a Python interface into x64 debug, or is just the default one? Like there's Duncan's scripting format. Okay, let's let it inject. I don't know if it just wrote the entire image. I probably should check that, but no, it's writing it piece by piece. So it's probably going to resume the thread. So then, no, you can just right click on the breakpoint, edit. Oh, cool. Okay. We can try that after this. Okay, so now it's setting the thread context. So it should be injected. So let's try this again, but I'm going to provide the PID. So Hollis Hunter and then do 5356. And I just got the PID from the top of this x64 debug session. So, oh, weird. Why isn't it finding it? Oh no, because it's the wrong PID. I don't know why I closed Process Explorer, but let's open that. Okay, so we want 1832. There we go. Yeah, wrong PID. Okay, so that worked. So kind of hacky because we could have just dumped the process anyways ourselves. So I'll have to figure out exactly why Hollis Hunter didn't work for that in the first instance, but I didn't want to like pre-do this before the stream. So these are kind of things that you run into when you do things organically like this, just because I think it makes them a little more interesting, and more fun to watch because you can see what the real struggle is like rather than everything just working properly all the time. Anyways, that's a whole other discussion. But in this Hollis Hunter dumps directory, there's a bunch of different information. So if we do type summary.json, then this provides like a nice summary of what occurred. So the scan date and time, the scan time in milliseconds, the number of processes scanned, the number of suspicious processes identified, I believe, or at least the number of suspicious images identified. Then we have the number of implanted PEs. So implanted is just another phrase for process hollowing that took place. And then it was injected into the remote process. So hopefully that makes sense. Okay, so then if we go into this process directory, then we can look at the dump report, which has similar information, but it just gives us kind of more specific information. So this was the PID that was identified, the module name, the size of the module, the dump mode. So it saw that this was unmapped, and then the status of the dump. And then there's also a scan report, which has also similar information, but is a little bit more verbose. So we have the image path, we had the number of implanted PEs again, and then we have the module information, blah, blah, blah. But what's cool about Hollis Hunter is it can do stuff like shellcode. So it has a number of heuristics for identifying shellcode, the memory protections, the mapping type, etc. So then if I open this, here, I'm just going to slide this across, open an IDA again, and then go to temp. Oh wait, where did we just dump that? Oh no, that was sorry. I'm just going to rename this to .bin because I don't like running stuff by accident, even though it is on my virtual machine. Okay, and then we get basically the same portal executable as last time, but dumped from memory using Hollis Hunter. So for those of you who were not on stream last time, we basically took a dump from this particular offset because this was allocated with heap alloc rather than virtual alloc. So it was not, this allocation was not made at a page boundary. This was made within this offset within this series of heap allocations. And therefore, we had to carve from this offset. So basically, I just dumped this, carved it, etc. Do you need to unmap it? No, I think it's unmapped. Like everything worked, so wouldn't I have complained if it was mapped in a map state? So, and then Sergey had good timing, because the other thing you can do is use a automated service. So hold on, I have like a million windows open. I should probably stop trying to use all these different profiles, but so I submitted this to Unpack Me. This is my personal submission history, but and this is why Unpack Me is so good, because basically it'll do everything we just did. So I'll show you another way to identify those Phorpiex, but you can do the free, where are they? I'll show you that in a sec, but there's definitely like a free pricing tier. So if you're just a researcher, you can sign up for Unpack Me for free and then do submit a sample like this. But yeah, what's cool about Unpack Me is if we scroll down here, we can see that there was a parent file, and then this unpacked all these files automatically. So the initial loader, and then finally it got to that final portable executable that we carved out of memory ourselves. So all this was done automatically. And not only that, but they have all this new enrichment stuff. I guess it's not really new anymore. It's pretty much the standard now. They have links to Malpedia. They link that it was indeed Phorpiex based on these YAR signatures that can show which file it matched. It has this Phorpiex label, etc. And they do like attack mapping stuff with the functionality that I was able to identify in that file. So pretty cool. So the next thing I wanted to show you is, okay, so what can we automate once we get to this point, right? We have this portable executable that we could manually go through and mark up every single function like we did last stream. But how can we automate some of this stuff? So first and foremost, we've already kind of automated the identification of Phorpiex. I wanted to show you another something else that I like messing around with called AssemblyLine. And I wrote an Unpack Me service for AssemblyLine. I think I need to fix some stuff because it wasn't working exactly how I wanted it to work before stream, but I think it's very outdated. But all that being said, actually, let me link this Unpack Me example here. So again, you can like register for free if you want. So AssemblyLine is a project written by the Canadian government, the Canadian Centre for Cybersecurity. And this is essentially a malware triage pipeline that you can set up yourself in a bunch of Docker containers. And it will do a bunch of the tasks that we manually did during our last stream. So let's submit this carved PE. So this is the carved one that we submitted last stream to AssemblyLine. This is a local instance that I just had running on like an Intel NUC. So it really doesn't need to be a powerful machine to get. Obviously, you're going to have issues with submitting hundreds of thousands or thousands of samples, but it's still good for doing research, especially just doing your own research. So if I hit upload and scan, oh great, I got signed out of this session. Hold on. All right, let's try that again. So upload and scan. And then, so basically what happens is AssemblyLine runs this against a bunch of different services. So do they have them on here? I can't remember. I'll show you all the services on this dashboard here. Basically, all of these services in this UI, I only have like a subset enabled. But basically, each of these services will run like some form of automation against a given malware sample. Oh yeah, that's okay. I just need to update the plugin. That's on me because it's my AssemblyLine plugin. But what's cool about AssemblyLine is basically it'll run all of this automation for you and then show it to you in a pretty UI. So similar enrichment to Unpack Me, but obviously by default, AssemblyLine doesn't do unpacking. So that's obviously the first part. But since we have the Unpack sample now, we can submit it to here. And we have a bunch of different of these services. So some of you might recognize like Kappa, the Kappa project from Mandiant. Cape Sandbox, you can set up a Cape Sandbox instance to run against samples. I don't have a Cape instance running on here right now, but I plan to get that working at some point. Characterize, there's a bunch of these different services that they've also written to do stuff for you, and I'll show you a few of those in a second. But config extractors, so this uses a number of different config extraction frameworks to try and extract information from malware samples. If you've used Cape before, then that includes the Cape config extractors. There's this deobfuscriptor that will basically attempt to automatically deobfuscate scripts, etc. So extracts a bunch of different information, whatever. We can I'll link the services list as well, and you can check those out. And probably one of the most important ones is Yara, which will basically pull Yara signatures from a external source, and then it'll run those against samples. Okay, so let's look at our submission here. So it's said it's suspicious, which isn't great. We kind of want to, we could make changes to make sure that it designates this as malicious. But let's take a look at some of the things that I identified here. So first and foremost, it extracts a bunch of important static attributes. Like it identified this is a PE32 portable executable. It gives you the associated hashes. We have the similar attack mappings to what's in Unpack Me. We have extracted data that it extracted automatically. So here, a similar Malpedia rule hit to what hit in Unpack Me for Phorpiex. So we can automatically identify, well, if of course there could be false positives in different Yara rule sets, but the Malpedia ones are usually really good. So in this instance, I would assess this is probably Phorpiex based on this rule hit. But what's cool is, well, it identifies it's probably Microsoft Visual C++ compiled. It has these techniques Yara rules as well. So for example, SCH init, I think this might be inaccurate because I don't think this is Utconos. I'm not sure what malware family that is. But in the last stream, we looked at the fact that it disabled the firewall. So it used Yara rules to detect that, which is pretty cool. It also identified that there's VM detection that we looked at last stream as well. And there's just like TLS hello packet stuff, which this might also be a false positive, but that's okay. But what's really awesome is all of those command and control servers that we looked at last stream, AssemblyLine carved those out automatically that are shown here. And then we get a network IOC that was also extracted. This WIP mania thing is used for network external IP acquisition stuff. So pretty cool. Okay, so if we look at the detailed view, what's cool about this is then these become labels in AssemblyLine, so that I can click on this and then it shows me which file it extracted it from by highlighting it. So kind of cool stuff like that. And then this is written to an Elasticsearch instance. And if you want in AssemblyLine as well, you can get the full Elastic elk stack installed, and then you can use Kibana to visualize this stuff. Grouchos is being recorded, so that'll be uploaded to our YouTube channel later this week. Okay, so yeah, so that's kind of it for AssemblyLine. What I thought would be fun next is if we used Binary Ninja's Sidekick to see if we can use AI to reverse this for us. So, hey, Almatis, how's it going? Thanks for joining. So, so this is the AssemblyLine, or sorry, not AssemblyLine. This is the Binary Ninja instance for that unpacked portable executable. So if I go to the start function, so we can see if AI is going to take all of our jobs. Yeah. So when I meant automating everything, I really meant it. So in this start function here, I think it's just a bunch of Visual C++ boilerplate, but let's see. Yeah, okay. So this is our main function here. So let's start. So let's see. Okay, so just to give you an overview of how this works. First of all, is this big enough for you? Is this text okay? I'll assume it's okay. So yeah, just to show you how Sidekick works. That's what she said. Okay, cool. Thanks, Almatos. So first and foremost, we have the disassembly on the left-hand side here, and then this is called the high-level intermediate language. This is just Binary Ninja's decompiler output, but we can change that to like pseudo C if we wanted to, and then it kind of looks a lot more like IDA. But since I'm pretty sure the intermediate language stuff, or I'm pretty sure the AI stuff uses the HLIL, I'll be using that. And what's interesting about this main function is it has this anti-analysis stuff that we saw last stream. But let's see what it can say about this. So there's like a lot of stuff that it's doing here. So there should be, so how this works is that there's, so there's these suggestions on the left-hand side, and this will essentially provide different suggestions throughout the database. And then it'll highlight, let's see. Okay, so there's just dead store elimination suggestions for this function. So what if I just accept all of them? So it just actually removed some suggestions that we probably didn't want, but that's okay. Okay, cool. So yeah, so it just did some stuff for us. So the first time I was just doing some indexer stuff. Okay, so did actually just do some stuff, which was useful. So I didn't name any of this stuff. Like, this is a brand new database. So I just did name callee functions, and then it marked up these functions here. So check for virtual machine environment. And so this is the anti-analysis stuff that we analyzed last stream, where basically it requires a handle to the physical drive 0, and then it uses device IO control to enumerate the physical drive information. And then it compares that against a number of virtual machine strings. So I'm just looking for those strings. Sorry, we did this in IDA last time, so I'm just trying to figure out where the actual string data is. Anyways, this is correct. So let's go back, delete a file and execute batch script. So that's effectively what it's doing. However, it is actually deleting itself using the batch script. Maybe I can coerce it to come up with a better name. By the way, for the conditional breakpoint. Oh, cool. Yeah, should I try that now? Plus work on the stack. Oh, for write process memory? Yeah, it was write process memory. No, AI at first. So that was in like a second unpack stage. So I don't have all the unpacked samples dumped, unfortunately. Mess around with this. So I'm just going to double check what write process memory. So I just want to see what Sergey was saying. So I'm just going to disable all these other breakpoints because they're going to be annoying. And then we're going to execute this. So it should, oh man, disable, sorry. So I just want to see what argument is being passed and see if we can automate this. It should be +8, okay. Oh, this is the DLL load. Let me disable that too. Hardware breakpoint. Oh man, hold on, sorry. There we go. Okay, +8, yeah. So I should just be able to do, isn't it 1, 2, 3. Did you say ESP? So we should be able to do, like this is the MZ here. Wait, what the hell? No, I just followed the stack address. So what do you mean with that? Is it like BP something? Oh, okay. Sorry, I'm like a total MSV CRT. Okay. So that's, yeah, so we want actually 452D, right? Yeah. Because it's dereferencing. Oh, 2. Oh, sorry, I just assumed that was, is that not right? Because it's dereferencing the pointer, right? But this isn't the base pointer address, this is the ESP address. So that's what's fucking me up. That's what the 2 is for. For getting 2 bytes from that address. That's okay. 2 is for 2 bytes, yeah, okay, cool. So if I do, you may need to double deref. I can't do that. 4D. So if I like do this, this should give me the address, right? Unknown expression. Crap, I just don't know how this works. Oh, I think you're right. It's a pointer. So how do I double deref? Can I do like a variable assignment like this? All right, let's do that. Yeah, okay. So can I make a script in here? Or do I have to like do something crazy? Okay, let's just open this in Notepad++. Okay, so if I do ESPP, oh really? I don't have to do the variable assignment? Yeah, okay, that's it. What are you reverse engineering? A sample of Phorpiex malware. I did that before though. Oh, it just doesn't work with the syntax, like the 2 thing? Oh, no, now it's working. Weird. Okay, so now how do I make it a conditional breakpoint? BP like that? Oh no, I just tried to set a breakpoint there. So if I do like right click, oh right, yeah, what you said earlier, sorry, my brain's like dead. Edit, breakpoint condition, like that, will that work? Dude, sick, that's dope. Okay, so then this should just work, right? Is this on your Patreon yet? Oh yeah, crap, I didn't do that. Because if it's not, you should put it on your Patreon. It's backwards because of the way the bytes are read. Yeah, let me double check. Let me remove the condition and get back to where we were. Yeah, that'd be cool. I need to start making mini courses. That's the plan. Nice. All right, we're here. So let's do that again. Okay, 2, 5A. Okay. So that evaluates to true. So then I assume that should evaluate correctly in this edit that we're doing. So let's restart this and then hopefully it breaks, because then that's like super good. Man, I need to stop drinking this bubbly because it keeps making me burp. Cool, yeah, it hit. Nice, thanks, Sergey. That's really cool. I will add that to our notes, which I should probably start. All right, sounds good. I'll see you later. The portable executable header. So if I go to this address that we were looking for using that conditional breakpoint, then this is the unpacked portable executable that we were looking at earlier. Yeah, so like basically you want to automate as much as possible, and by creating those conditional breakpoints, you can skip all the write process memories that would occur that we're not writing a process header, or sorry, a PE header, for example, or an MZ header. So kind of just a hack to get to the product you want quicker, I guess. So pretty cool. Thanks to Sergey. Okay. But more often than not, you won't see a legitimate application using write process memory. So a lot of like hardcore packers avoid it. But we could do more complicated stuff for more hardcore packers. But yeah, something to explore in the future. So getting back to our AI reversing, let's see if we can do it. Okay, so I'm just going to apply these variable renamings. So on the left-hand side, you can see suggestions. And then for this particular function, delete file and execute batch script and apply. So then it just renamed. Oh, there we go. Never mind. So then it just renamed this module name parameter and this temp path parameter. So that's pretty cool. Let's go to this function 403 D40. So it just says get program path and check for x86. So sh get folder path. I can't remember which CSIDL this is. Let's take a look at our IDB. So this is the carved. So this is the one that we manually reversed last stream, so we can kind of use it as our sanity check. 403 D40. Get our using program files. Oh, right. This is the program files path. Okay, so didn't pick that up, but let's accept it. All right. Okay, let's 404 EF0 has a bunch. Okay, so I'm gonna rename all these variables. Okay, so just did a bunch of different stuff. So I did this zone identifier path, this module name, this Windows directory. So like I'm surprised it didn't apply this expand environment variables to LPDST, because this is effectively expanding the Windows environment variable and then assigning it to this variable. Okay, so then it has renamed this as well to copying and executing files, checking for virtual machining, creating registry entries. So like that's an accurate description of the function. Let's see what else it did. So create and wait for thread. If we look at this, create thread, I would say that's accurate as well. Create process with startup info and process information. Win manager path. So let's go in there. Yeah, create process A. So yeah, it looks okay. 403, 4C0. Okay, let's apply these. So snapshot handle, whatever stuff we would just probably mark up ourselves, right? So just kind of saving time in general. Nothing mind-blowing here. Or wait, hold on. It had a markup suggestion for this. So you can set comments as well. It'll automatically come up with a description. So let's apply that. So this code checks if a process with a given name is currently running on the system using the Windows API create tool 32 help or create tool help 32 snapshot and iterating through the list. Yeah, that's correct. Pretty cool. So if we go back here, let's see what else we got. So on the left-hand side here, we have, yeah, let's apply this comment as well. So I want to see if start, we don't really need that stuff. So let's look at some of the C2 functions, for example. So there should be a lot of suggestions for these ones. Let's see here. Name callee functions, so let's do that. Okay, so this just renamed a bunch of functions. So let's go into dead store elimination. There's a bunch of dead store elimination for this current function. I like the mile long function name. Me too. It's very descriptive. It's kind of, I don't usually have function names that long, but okay, drive type. Let's do that. Manage files and directories on drives. So that's not really what it's doing. It's like checking, I guess it's kind of managing them, but it's actually infecting them as malware. Okay, so let's apply this and see what it says. This code manages files and directories on drives by iterating through logical drive strings, determining the drive type, and creating or managing files on the directories accordingly. So like, it's not incorrect, but it's just using it for USB worm functionality. Okay, so let's see what this can do here. 40. All right, we got a ton of suggestions here. Okay, so we got file path, writing files. Okay, yeah, so these are all really like high level stuff, but like this function is like effectively creating LNK files that it's using to manage these worm propagation things. So, okay, so are there any other suggestions for this function? Weird. Okay, I guess that's it. So let's go into some of these subfunctions and see what it gives us. See, like this function's massive. So it's it'd be probably pretty hard for the LLM to determine exactly what's going on. Let's look at the other threads, because that has the C2 functionality that I was mentioning before. Just get logical drives, name callee functions, let's do that. So yeah, this looks like it's doing some cool stuff. So searching for files and performing operations. Also very generic. Let's apply these. Okay, so let's see what else it says here. So find file. Again, it's looking for particular files. Let's see what else it's suggesting for this function. So it's searching for files and performing operations. This code searches for files, performs various operations on them, such as deleting, copying, and creating archives, returns a handle to the last file found. So yeah, like effectively that's correct. Basically, this was doing the self-propagation stuff. So yeah, effectively that's correct. So what I spotted earlier, so like these renamed functions down here, there's some cool ones like calculate CRC32 checksum. So if I go there, this is a CRC32 checksum, so it found that for us. Calculate system time and assign values to pointers. I think this was just making sure the system time was correct for the worm functionality. I'm pretty sure we didn't reverse this fully last stream. Let's see. The LP system time. Yeah, okay. So I'm fairly certain this was just marking up the system time for the file. It says that's dead code though, so maybe it's not used. So this is checking the CRC32 checksum. Yeah, thank you. All right, so let's go back to where this is called. Copy file with error handling. There's a bunch of dead store eliminations, so let's do that. Again, cleans up the function nicely. Let's do this. Create process with startup info. Searching for files and performing operations. Let's go there. Okay, yeah, this is the one that we looked at before, so let's apply this. This code searches for files, performs various operations on them, such as deleting, copying, and creating archives, and returns a handle. Yeah, so that was the one I was talking about earlier. Find close. Okay, it returns the closed handle for some reason, but I don't even think that's used. Because we go here, see it's not even passing the return value. Okay, so let's go back to where this is called, because I want to look at the C2 stuff that I keep saying I'm going to look at and then don't. So this is, here we go. Okay, do you have any suggestions for this one? Dry letter. Okay, let's do that. Okay. Okay, so this one should be pretty easy for it to figure out. Name all callee functions. Maybe it doesn't have any suggestions for this one. It should though. 401490. Okay, let's go back. Okay, 404E. Name callee functions. Like I think name callee names. Enough Robux, yeah. Okay, where was that? Call 401-500. So something that would be good, Jordan, is okay, cool. Exit thread if initialization fails. EB0, E70. Okay, let's do that. Okay. Yeah, so it initializes this struct offset. Okay, let's just go through these suggestions. Okay, I think that worked. Calculate CRC32 checksum. Did it create a struct? Yeah, it did. Okay. Okay, I'm just gonna keep letting it do its thing. Data struct, structure. Okay, those are all the suggestions for that one. Let's apply these raw archive ones. Oh, cool. Okay, it keeps giving me more suggestions for this one because I'm gonna keep letting it do its thing. So this is starting to look pretty nice. Are these suggestions based on AI? Yeah, L models, yeah. That's okay. So yeah, basically Sidekick uses a bunch of backend LLM models to make these suggestions. Okay, so let's do all this did code stuff. So like that just marked up a whole bunch of different stuff, right? So again, saving us a bunch of time, get source file size. Pretty cool. Again, we didn't really reverse this function in depth, but basically from what I gathered last stream, it was essentially infecting raw archives. Map view file, calculate, yeah, with this Phorpiex malware. Yeah, I agree. El Matos. Then this one was doing. Oh yeah, so this basically looks for all these different file types and then performs the worm functionality with each of the file types. So I want to see that raw archive one. So this code creates a raw archive by copying the contents of the source file to a destination file along with a header containing the archive name and a checksum. Yeah, so like essentially that's what it's doing. All right, let's get out of here and then go back to our C2 functionality. And then we want to go to this. Okay, does it have any suggestions for this one yet? No. What about this one? Okay. I'm just going to accept all these to get them out of the way. 401-500. Where's 401-500 again? Okay, this is the C2 stuff. Let's make it do that. Is this being called? Oh, okay. All right. So, yeah, I was just going to accept all these. And then I'm just going to go through the list and see what it looks like. Okay. Search path. Okay, so let's do that. So send printf, search path, create file. So I don't know why it thinks this is a search path. Because this winmanager.txt is actually being created, I believe, for the worm propagation functionality. Oh, cool. Okay. So yeah, so last stream, I wasn't sure if it was setting the hidden attribute. So I picked that up. So create hidden file and app data directory. So that's pretty cool. So let's name the call functions. I don't think there's too many left in here. So, okay. So I accepted all those. Let's see if it gives me any more. Okay, locale info. Create file and app data directory and generate random string. So, so this was for the system identifier that was used in the CT request that we reversed last stream. F10. Oh, cool. Yeah. Oh, cool. So I can just make it. So if I do, yeah, cool. So this was doing enhance. Yeah. Okay. So let's, again, I keep getting, now that I know I can ask for more suggestions, that'll help a lot. Let's go back to start. Does the chat thing give you ChatGPT looking responses to your questions? Yeah. Yeah, exactly. So it's kind of a way of like interacting similar to ChatGPT. So I could be like, what does this function do or whatever. It was working on a previous stream, so but the suggestions are working. So that's basically like what I was going to get the chatbot to do. So let me go down to the C2 stuff. Okay, so F10. This isn't the C2 functionality, but I was trying to get it to copy string from clipboard. Yeah, cool. Based on input. This copies a specified string to the clipboard based on the input string, which with different characters being copied depending on the input character. Yeah, that's essentially correct. It just didn't identify that they were cryptocurrency addresses, but no suggestions. Okay, that's cool. Okay, let's do yeah, exactly. That's what I wanted to do. Okay, so let's go back to this guy. Manage files and directories and drives. So let's get suggestions for this one. Name the call functions. Convert IP address or hostname to unsigned integer. That's not quite right. Basically, this is getting host by name, so it's actually resolving the given host name. Let's see how these arguments look. So host entry, IP address, converted IP address. Okay, I can see why it would basically convert IP address or host name to unsigned integer, because it's effectively, but get host by name can resolve a given DNS name or a given host name, not just an IP address. So if I do like host information corresponding to a host name, okay. So yeah, that looks good. Connect to server via TCP/IP. Okay. Cool. So it's doing a bunch of stuff, and it looks like it's actually right on a bunch of stuff. So we'll look through all these. So add socket and wait for activity to set. Okay. So yeah, this is setting the select. Add socket to set and wait for activity. So okay, that's fine. Then we have check if string is empty. Okay, so it's just comparing it to okay, so that's not right. So if I change this to a string, then ask it for more suggestions. Will that correct it? I don't think so. What if I like force rename it? No. But basically this is comparing the input string to X, not if it's empty. You can use Binja to add network multiplayer to MS Paint. Yeah, totally. Okay, so let's go back to that C2. Oh yeah, so this is the handle IRC messages. So this is actually pretty accurate. Let's name those call functions. Okay, yeah, so now it renamed it to, after deleting, I think it's just because this operator deletion thing. And that string and string, why did you think it was this? Whatever. All right, let's do all this. So let's see, send IRC message. Let's do all this. Captain MA user, not really. It takes like a couple minutes. I saw it was like connecting to Hugging Face, so I don't know if it downloads like a local model that it uses to check for stuff, but on my like typical internet connection, it didn't take very long. Okay. So send, let's see, sends messages based on the specified message type parameters in socket. Yeah. Oh, I guess 1 gig is pretty big. Is that a local model? If you don't want to divulge anything, that's fine. Since it's a commercial product. Yeah, there's at least one local model. Cool. Okay, yeah, let's do that. Ironically, it's one of the best, and it's in the free version, though with one caveat. Specifically, the structure recovery can run even in the free version. Yeah. No, that's a good kill hit. No. All right. I'm actually before one thing I'm gonna check for is updates because I was away for a bit, so you guys might have released an update. Oh, I'm also in the dev branch. Maybe that's why. I should add that as a disclaimer that I'm on the dev branch, so stability is not guaranteed, and I need to update, which is updating right now. So maybe that'll fix everything. Sorry, I should have done this pre-stream, but in fact, super close. We did a fresh stable just today. Okay, or just yesterday. Malware analysis seems wild. Yeah, clutched. It is pretty wild, but don't get like too intimidated. It's not horribly complex once you kind of like break it down and work on it piece by piece. No. Okay, so let's see if Sidekick is working. But clutched, we're trying to use AI to help us reverse engineer and do malware analysis automatically. So let's okay, while this is installing, I'm actually gonna run to the washroom. And before I do that, I'm just gonna run a quick commercial. So we have a malware analysis course that teaches you how to do all of this stuff from the very basics to getting all the way up to like analyzing the process injection and unpacking stuff we did. So I'm just gonna run a quick commercial for that, and I'll be right back. And then I'm gonna run to the washroom as well. Hey everyone, my name is Joshua Reynolds, and welcome to the InvokeRE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right, I'm back. How's everybody doing, by the way? All right. But let me try that real quick to see if what did at least work for me just now. Oh, okay, interesting. So it's literally mine. Oh, cool. I think it's working now. Hell yeah. Let's go. Yeah, definitely temporary. So I think the update fixed it. All right. So let's try and speedrun what we just did this whole time. With the chat. And hopefully I don't hit throttles. Since now I know how to do stuff. Check for a virtual machine environment. All right. I'm super curious what it says about those strings too. Yeah, I can just jump to that function. Hold on, I have it in my... I think I should be able to find it pretty quickly. All right, let's... it's one of these. It should be in the clipboard one actually, so this one. Okay, so let's add all the suggestions. Yeah, I think when I'm on stream, I just tend to use the buttons to show people what I'm doing, but usually I do. O.bin. Yeah, makes sense. Yeah. All right, so let's apply these suggestions. Can you identify what strings are being in the clipboard? when the correct character is found. Nice, awesome, home slicing. Yeah, the UI is really nice compared to other reverse engineering products. Yes. Oh, cool. I like summarized it. That's nice. What types of maybe my prompt engineering sucks. What are these strings used for, though? Strings are used part of the conditional replacement mechanism. Are these I'm just gonna stare at a basket. Are these strings related to cryptocurrencies? Like everything, I think my questions just suck. Okay, it says it's not related to cryptocurrencies, but yeah, but like this is a hard problem for AI. I feel like have you thought of creating models that are specific to certain types of reverse engineering? Like, could we create like a malware reverse engineering model that would be able to like recognize functionality like this? Other types of tuning. Yeah, that's what I was meaning. Checks the first character input string based on the value, copies the specific string to the clipboard. The function returns 1 if the operator is okay, cool. Yeah, like to me that's pretty good, but 401490. So what does this function do? This function continuously monitors the system's clipboard for changes. When it detects that the clipboard contains data, it retrieves the data as a string, unlocks the clipboard, and then passes the string to sick. 401490. Can I get suggestions for this? I wanted to rename it. Copy string from clipboard. Okay, there we go. So let's move on to the next stuff. Let's do this C2 functionality again, but I want to ask it questions about the C2 functionality. What's cool about this is there is like consistency though with the model, which surprises me. Like it's almost like deterministic, which I guess makes sense if it's going to take the exact same token paths each time. It does do some things somewhat randomly. Okay. Oh, the names do change. Yeah, it's probably just my like anecdotal evidence. Initialize WinSock. I think that's just like initializing WinSock structures to 0. Like this giant. Yeah, let's just zeroing out this data directory allocation. Well, it's not even an allocation, it's a static buffer location. Let's see what the AI says. I think it didn't really say a whole lot last time. It said just zeroing out stuff. Yeah. I think the long function names are okay though, so okay, let's do this one again. I want to see if I can coerce it into getting it right. I wonder if it will give a new name this time. Yeah, me too. This one, it was just saying it connected to an IP address. Like this basically said the exact same thing. I don't know if it was exactly this. I can look at the recording later, but sock stream. Yeah, like this is correct, I think. But like, what does this? Yeah, sorry, Jordan, I just saw your comment, but yeah, it's giving good names. I'm curious if the difference between the notebook interface when you say. I'm curious the differences between the notebook interface when you ask that. Yeah. Like these are way more descriptive. So maybe you guys might be restricting the size, which makes sense because you don't really want like this whole block of text being a function comment. Yeah. Okay, so if the inet returns, this indicates either an error or the input. Yeah, like that's wrong, but I kind of like that interpretation. It's just -1. So like if I make this -1 to a, I can't remember the hotkey. Oh, display as signed decimal. There we go. All right, now let's see. I just want to see if it picks that up. It probably will. It would make sense. Oh yeah, and Jordan feature request. Like the up arrow key you should do like some question history, so I can just hit like the up arrow key to get my last question. Yeah. Oh, and another feature request. I guess you don't really want that because of the way this menu works. Oh yeah, I like that. I like the reask. That sounds good. Convert R1. Weird, it's still interpreting it as all Fs, even though it's displayed differently. So I'm assuming the high-level intermediate language, or like however Sidekick's getting the data is not as it's displayed. Okay, so let's keep going. Oh, you use sudo C. Okay, that makes sense. So if I go back, yeah. All right. Not sure why. Yeah, I think it's just, I don't really know how you could fix that, to be honest. Okay. Okay, that looks good. That's basically the same as last time. This was generating that unique identifier. That's using the C2. Nice. Redundant. Oh, that's cool. Jordan, have you had anybody who's like, oh, hold on, I'll read your comment. So OneNote 2 is it generally works well when you do have some context, to just make it a quick name yourself. Okay, yeah. I was just gonna ask if you've gotten feedback that it's good at like identifying potential vulnerabilities. Because I don't really do vuln research, but I'd be curious if it's good at like, oh, it's poor. Yeah. So pretty much just like, yeah, I bet that can be improved upon too with tuning. But okay, yeah, it's not surprising. Okay, so I think this is actually something I didn't notice last stream. I think this is creating a temp or a hidden file in app data, and then what are these? Are these initialized somewhere? Yeah, I think this is using so now I want to see if it changes interpretation. Being able to see both XREST and suggestions in 4.0 above makes me so happy. Yeah, it's really nice. I don't think this is going to be able to, like, that's very non-descriptive what I provided, but and not even actually very right, but yeah, nice. It's not for persistence, but I'm surprised it was able to figure that out. Operationally, This is awesome. I wish Sergey was on stream. Because this is like basically, we use MW underscore for everything. So I wonder if it like scraped, yeah, like I wonder where I understood that from. C2 is common term for, yeah, blah, blah, blah. Cool. Yeah, that worked a lot better. So I'm going to try that with some other stuff. All right, so we have ping, we have private message. This is kind of big, so cool. So performing various actions based on received commands. Command handling. Yeah, crap. Why can't it see the data? Let's see if I make these C strings, if it works. It should work. Okay, let's try this again. String token. Yeah. So string token. No, I think that it's actually looking for a space. Yeah. So I think I just did that, right? But I do think this is actually looking for a space, and then character. String copy, ping. Does it have suggestions for this guy? 4048880. The string family of functions don't have proper type info. If I click on string token, tail call, it looks like it does. Is it because it's like these are char stars? But like I think those are right. I think it was just I wasn't seeing because there's this operator new, which from a assembly perspective, yeah, I think it was because the operator new. Oh, that's super weird. It's behind chat. Oh, shit, sorry. Can you see now? Not a big deal, I think I see. Yeah, like, so I don't know why the high-level IL interprets this as a operator new when it's doing a string and string comparison of these two arguments. Yeah, I'll share it. I'll share the crashed one, and I'll just share all of these. Okay. Cool. All right, so let's see what it said. I'm sorry, I don't know what to say. I think I was like clicking around, so let's do this again. I just don't want to click out of this function, but like overall, I would still say I'm like extremely impressed. Because like a lot of this busy work you don't really want to be doing all the time, and then you can just fix whatever gets wrong. Okay, so let's see. So cool, yeah, it's picking up the strings now. Okay, so all you have to do is if, for example, like you have, okay, so let's see, initialization set to 0. Okay, that's right. It sends a predefined IRC command using the send IRC, okay, including the channel or command net, tokenization and command handling. If the initialization condition fails, it tokenizes the input string with string token, splitting it by spaces. It iterates through the content of these tokens. It appears that to be looking for specific commands with markers tokenized with the logic at. Yeah, that's correct. And then checks if the command is ping. If so, error handling. I don't think this is error handling, but that's okay. Check in response, proof message, command handling, proof message. Cool. Delete file based on commands. Let's look at this. Operator delete. Yeah, like read file. Okay, so this is a little bit different. Can you, sorry, I got distracted. Okay, so this is doing this is doing the external IP stuff, and then it's comparing it to these offsets. Find empty slot and store value. Interesting. I feel like I should have set those strings. Yeah, I think if those were set automatically, it would have been able to identify more. String path file name. Did it pick up the... Okay, this is a whole different function. Can the suggestion learn from the analyst analysis? Yeah, that's kind of what I was talking about earlier. But you can't. But you guys aren't doing tuning feedback, right? Okay. Execute file leash process exit. Yeah. So like this is right? Like this is what we reversed last stream. If the command rmrf is received, it executes delete, cleans up the WinSocket APIs and exits. Command processing processes additional commands. Conditional. Okay, I want to see if I change like so like this URL is used to acquire an external IP address for the infected machine. So I want to see if it picks that up. What do you mean you don't know what to say? Just like a specific conversation thread we provide via chat, via change of types. Yeah, cool. And we'll never tune the models based on commercial users' usage as data. We haven't started doing it on non-commercial users yet, but we plan. Cool. Yeah, that makes sense. Okay, let's see if it picked up that variable name change. Using it after the opening fetch data from the internet. Yeah, okay, I don't know. Yeah, we can leave that for now. Oh man, there's so much other stuff in here. Did it get the admin? Maybe this is too long. Because I didn't get the rest of this stuff. Let's see. Which indicating the user is on administrator WS printf. Cool. Yeah, so that's right. And then I'm asking it like purposefully generalistic questions. If the get path turns 0, indicating the x86 architecture WS printf. Yeah. So it didn't pick this up, so I just want to see what enum does the value, what does map to when calling sh get folder path a. So like I tweeted about this earlier. I'm kind of trying all new stuff that I haven't tried before, but Sidekick is really good at identifying constants. Let's see. Standard is CSIDL. However, shget folder and a successor known folder ID might be custom application specific value. Okay. And to be fair, when I Googled this and stuff last time, it wasn't coming up, but I realized it was program folders. But like, I bet I could find an example that it does it. Well, it found the CRC32 function earlier, so that was a good example because CRC32 has that constant. All right, let's. What other interesting things can we try? Does anybody have any ideas? Are you all falling asleep? Okay, let's do. can't remember what this does. Oh, this does receiving. Oh, I'm just gonna like apply. Oops. Cool. There, so I just applied all of the suggestions. So let's go back to start. I'll apply these. See if it keeps giving me stuff. Cool. This function receives and handles IRC commands from a socket, continuously reading data from the socket until a command is received and then passing it to another function for handling. So that's right. I don't think it'll crash. This code connects to a server via TCP/IP, sends IRC commands over a socket, and receives and handles IRC commands from the socket and handles various ioctl results. I don't know why it says ioctls, but yeah, that's really cool. All right, let's go back to what this is called. All right, so we have this stuff. Okay, so I can be like, what type of drives is this function enumerating? Because these map to constants, or enums. Cool, see? So drive fixed. So the condition checks for return value of 3 for fixed drives. Cool. What drive string is this looking for? C. CD. Cool. So, okay, so I'm new to RE learning Binja, and I was wondering how it detects when a function is just something like memcopy. So maybe Jordan can answer that better than me, but typically a memcopy would just be a like standard set of operations in the disassembly, for which it has like a predefined set of rules that it says like if I see these types of instructions, then it's a memcopy. Like the function was being automatically named memcopy, preferably not. It's kind of a long answer. Okay, so this is what Jordan said. Oh, that's a fun question. It's kind of a long answer. Sometimes it's because the function is literally an import from another library. Yeah, I should have said that. In which case it's a specific file format itself, and you can know exactly what it is. Sometimes it's being inlined or just compiled into a binary without symbols. That's the hard case. The short answer is we have a set of heuristics, so basically a set of rules that tries to understand the generic behavior and creates a fake function to replace it. That's like, yeah, cool. Okay, so let's see, searching for files and doing operations. Oh wait, that's the one we were just in. So it calls it recursively. Or recursively enumerates directories because it's doing set current directory to the file name when it finds a directory, and then recursively enumerates them. Okay, create raw archive. We looked at that before. Create and copy random file. All right, I'm pretty tired, so I think I might call it. But yeah, that was super cool. We like generally from a high level point of view, it was able to identify a lot of the functionality that we reversed last stream. I think if like LLMs can be tuned to be specific to malicious functionality that malware is doing, which is basically what my brain was doing, then I think it could be better at identifying like that this is actually malicious functionality. But from like a high level, it is quite good at identifying exactly what the functionality is doing without it interpreting as being malicious operations, right? So yeah, like it's really good for markups, constant identifications, something we didn't really explore this stream because this was kind of more beginner stuff, was automatically writing automation, which I've used it for a lot, which I mentioned in the blog post that we wrote. I'm going to link that. Let's see. So yeah, we put out this whole blog on automating CACbot analysis with Binary Ninja, which we basically went over a whole bunch of different stuff in 3 streams, and then I summarized it all in this big blog post, and also did some more on the side. So check that out if you're interested. That's pretty advanced, since this is like a quote unquote beginner stream. But yeah, that's it for today. Jordan, I'm going to get you all this stuff. I'll send it to you right now once I close out the stream. And if any of you all want to join our Discord, I'm just going to shoot it. I'll get you the Discord link. So here's our link to our Discord. And again, if you're interested in learning malware analysis, check out our malware analysis course here at training.invokere.com. Introduction to Malware Binary Triage. So we basically go over everything that we did today and in the first stream in detail, with video walkthroughs and all these different modules. And again, you purchasing this course just helps out the stream, so we can use cool tools like Binary Ninja and IDA and Sidekick, which are all commercial tools, so they cost money. But yeah, so if you want to check that out, it's here. And I'm just going to run one more ad for that, and I'll close out the stream. So thanks again for the support, and I'll see y'all on the Discord. Take care. Hey everyone, my name is Joshua Reynolds, and welcome to the InvokeRE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you.